What we're able to do now that was never possible before is combine molecular biology with these understandings of the physiology, the electrophysiology of what's going on, so that we can really control it at the genetic level.
I love the caption of an electric face. It's a really perfect way to explain what it is that you're seeing in that video. So we're actually able to see where cells are acting as a battery where they're accumulating negative charges. And the amazing part was that those negative charges overlap in areas where those cells are going to become parts of the face.
So just cell divisions, lots of activity, front end of the spinal cord. There goes the brain, mouth, pharyngeal arches, eye, nose, ear. So just cell divisions, lots of activity, front end of the spinal cord. There goes the brain, mouth, pharyngeal arches, eye, nose, ear. All of these things are in some way being regulated by a single type of signal. That is just beautiful to me.
The finding suggests that what we thought about how cells know what to make is incomplete. And this is a way to sort of finish that story, or take a new road for that story.
10 years from now, how will we fight disease? At GSK, we're exploring the medicines of the future, like bioelectronics, a tiny implantable device that works with your nervous system. No pills, no injections, just modifying your electrical signals to help treat chronic diseases like asthma, diabetes, and arthritis. To discover a medicine that no one's seen before, you have to look where no one else has.
I'm thrilled to be announcing today the formation of Galvani Bioelectronics, a jointly owned new company formed by GlaxoSmithKline and Verily, formerly Google Life Sciences. Galvani Bioelectronics will be dedicated to the research, development, and commercialization of bioelectronic medicines. It will build on the great know-how and technologies developed over the last 3 years at GlaxoSmithKline, where we have demonstrated the feasibility in preclinical stage of bioelectronic interventions as a mean to treat chronic diseases, and Verily's great knowledge and capabilities in miniaturization and device design and engineering. We have the intent to take this concept from preclinical to clinical proof of concept over the next 3 years, and hopefully, if all goes well, to the first commercialization over the next more or less 7 years. A great opportunity for these two companies to join their efforts together and have a transformative impact on patients' life.
When TT fields are activated, a uniform electric field develops within the cell, and dipole molecules are subject to rotational forces. This causes tubulin dimers to align with the field, inhibiting microtubule formation, leading to metaphase arrest, prolonged mitosis, and cell death. Deformed spindle fibers resulting from TT fields can also lead to abnormal DNA segregation between daughter cells, and eventually, cell death. In cells that manage to complete metaphase and enter cytokinesis, the hourglass shape that forms leads to a non-uniform electric field within the cell. This results in dielectrophoresis, net forces on polarizable objects toward regions of high field density, concentrating macromolecules and organelles toward the mitotic furrow, leading to structural disruption and cell fragmentation. The extent of electrical non-uniformity in dividing cells is dependent on the frequency of the TT fields, the electric properties of the cell, and the orientation of the dividing cell relative to the field.
I'm going to show you another clip of a woman named Lydia. Lydia is a 66-year-old farmer in Switzerland. She was diagnosed with lung cancer 5 years ago. She underwent 4 different regimes of chemotherapy over 2 years, none of which had an effect. Her cancer continued to grow. 3 years ago, she entered the Novacure lung cancer trial. You can see in her case, she's wearing her transducer arrays, one on the front of her chest, one in the back, and then the second pair side to side over the liver. You can see the tumor treating field generator, but importantly, you can also see that she is living her life. She's managing her farm, she's interacting with her kids and her grandkids, and when we've talked to her, she said that when she was undergoing chemotherapy, she had to go to the hospital every month for her infusions. Her whole family suffered as her side effect profile came and went. Now she can run all of the activities of her farm.